Hello everyone, let us see next point of this chapter. That is, we have just seen expansion of sine a multiple of angle theta, that is n theta. Now we are going to see expansion of sine raised to n theta. The n is in the power of sine or cos. Okay, here some notes are there. If x is equal to, let x is equal to cos theta plus I sine theta with one complex number, then 1 upon x, that is its inverse, becomes cos theta just minus I sine theta. If you add these two, we get 2 cos theta. Okay, because our sine term is 1 plus and other is minus. If you subtract x minus 1 upon x, cos gets cancelled and these terms becomes 2 times I sine theta. Okay, now one more thing. If x minus 1 upon x is 2I sine theta, then x cube minus 1 upon x cube becomes 2I sine 3 theta. Similarly, x raised to 5 minus 1 upon x raised to 5 becomes 2I sine 5 theta. X raised to 7 minus 1 upon x raised to 7 becomes 2I sine 7 theta. Whatever the power of this x here, that will be the multiple angle of sine theta. Okay, here 5, here 5, here 7, here 7. Whatever the power is there, it should be in the multiple of theta here. Okay, these are the formulas we need to this formula we need in the examples. Okay, let us start with the example. Expand sine raised to 5 theta in the series of sine multiple of theta. This is the question. We have to expand sine raised to 5 theta here first. Now let us start with, let x is equal to cos theta plus I sine theta. 1 upon x is equal to cos sine theta minus I sine theta. Now we need expansion of sine, that's why we use x minus 1 upon x, this equation. Therefore x minus 1 upon x becomes 2I sine theta. Now we have to make the power on the both side of this equation, which is required in the example. Sine raised to 5 is there, we need to find out sine raised to 5, that's why we take raised to 5 indice on the both side of the equation. That's why it becomes x minus 1 upon x raised to 5 is equal to 2I sine theta raised to 5. Now simplify this. This is in the multiplication, we get 2 raised to 5 I raised to 5 sine raised to 5 theta. I raised to 5 theta, we know I square into I is minus 1 into minus 1 plus 1 into only I is remain. 2 raised to 5, keep it as it is because it is a constant, and sine raised to 5 theta. Now take this sine raised to 5 theta here and 2 raised to 5 I on that side, we get 1 upon 2 raised to 5 I into bracket this x minus 1 upon x raised to 5. Okay, now using Pascal triangle we have to expand this equation. That is a minus b bracket raised to 5. You are in Pascal triangle, for minus you have to put just plus minus alternating sign. Okay, first term a raised to 5, that is x raised to 5. Second term minus, because minus is sign there. 5 in Pascal triangle, a plus b raised to 5. We have fifth row is 1 5 10 10 5 1. Okay, accordingly we have to expand this x raised to 5 minus 5 x raised to decreasing power of x, that is x raised to 4 into 1 upon x, that is b term, plus 10 in the Pascal triangles 10 x cube 1 upon x square minus 10 x square 1 upon x cube plus next number is 5 x power reduced x only 1 upon x power increase, that is 4, and last term minus 1 into b raised to 5, that is 1 upon x raised to 5. This is the expansion of a minus b raised to 5 using Pascal triangle. Okay, now cancelling the powers, simplifying, we get x raised to 5, this x raised to 4, x 1x is cancelled, here x cube remains, here x cube, here x square, 1x remains, here x square, here x cube. Wow, x square gets cancelled, denominator 1x remains, x into 1 upon x raised to 4, x cube remains, and here 1 upon x raised to 5. If you observe this, Here x raised to 5, here 1 upon x raised to 5. Combine this first and last term here. We get x raised to 5, put the brackets, x raised to 5 minus 1 upon x raised to 5. Now these two terms, second last terms. 5x cube plus 5, 1 upon x cube. Take 5 common from these two and take minus also common, because we need first term as a positive. That's why x cube, bracket x cube, and we take minus outside. That's why this sign becomes minus 1 upon x cube. Now middle two terms remaining, 10 take outside and x minus 1 upon x. Okay. In this way only you have to merge the first and last, second and second last, third and third last, this way only, and take those numbers also common. Now if you observe this, we have to need formula here. See, x raised to 5 1 up minus 1 upon x raised to 5 is 2i sine 5 theta here. Okay, 3 as 5 as it is, x cube minus 1 upon x cube is 2i sine 3 theta. X minus 1 upon x becomes 2i sine theta. These are the formulae. Put this formula here in the steps. Now here 2i is common. Take a common and cancel with this 32 and I. It becomes 16, I gets cancelled, and sine 5 theta minus this 5 as it is, 2i gets cancelled, common and gets cancelled with this 32i sine 3 theta plus 10 into this 10 as it is sine theta. 2i we have already get cancelled with this 32i, that is 16. That's why sine raised to 5 becomes this total term, which is our required answer. In this way we can expand any number of power. Okay. This is homework for you. Expand sine raised to 7. Okay. Take here instead of 5 you have to take only 7 on both sides and expand using Pascal triangle a minus b raised to 7 and combine the terms, we get this answer. Okay, this is your homework. Let us see now cos. Expand cos raised to 6 theta. For cos, let us start with the same. Let x is equal to cos theta plus I sin theta. 1 upon x becomes cos theta minus I sin theta. We need cos expansion, that's why we have to use this x plus 1 upon x, this equation. Therefore adding these two we get x plus 1 upon x becomes 2 cos theta. Now we need power 6, that's why taking power 6 on both sides. We get x plus 1 upon x raised to 6 is 2 cos theta raised to 6. Simplify, we get 2 raised to 6 cos raised to 6. Take this on LHS side and you can put 2 raised to 6 as it is. At the end you can also remove that 2 raised to 6 on LHS side, RHS side. And 2 cos raised to 6 theta becomes 1 upon this 2 raised to 6 comes on denominator. We get 1 upon 2 raised to 6 into this term. Now expand this using Pascal triangle, that is a plus b raised to 6. A raised to 6 plus 6 a raised to 5, that is x raised to 5 into b, that is 1 upon 6 x plus 15. Next number is in Pascal triangle 15. X raised to decrease the power of a first term, that is 4, x raised to 5, x4, x3, x2, x1, x0. Okay, and increase the power of 1 upon x, that is second term, that is 0, 1 upon x raised to 1, 1 upon x square, 1 upon x cube, 1 upon x raised to 4, 1 upon x raised to 5, 1 upon x raised to 6. Okay, and what are the coefficients? 1, 6, 15, 20, 15, 6 and 1. Okay, now simplify the powers. Here 1 x gets cancelled, x raised to 4. Here x square gets cancelled, x square remains. Here x cube gets cancelled, 20 only there. X square here gets cancelled with the denominator, 1 x square remains. 1 x gets cancelled, we get x raised to 4. Here x raised to